Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled SDO Observes a Coronal Mass Ejection. So, what do we see here? Well, here we see a time-lapse video. This is about 2 hours worth of data taken on April 24th of this year by the Solar Dynamics Observatory, or SDO. Now, this is a sun monitoring spacecraft that studies, as you might expect, our sun. And here we're going to see what is known as a coronal mass ejection. So let's go ahead and play the video and just put it on a repeat so we can look at it as we discuss it. Now we can see the material here right as the video starts being expelled from the sun. This is called a coronal mass ejection and is an ejection of a lot of matter. How much? Well, we're talking about billions of tons of material that is being expelled outward by the sun. How does the sun do this? Well, the sun has a very strong magnetic field. But not only that, its overall magnetic field, but its magnetic field is concentrated in specific places. It gets twisted and tangled. And what happens is that eventually it can simply snap. So it can get so stressed that it essentially snaps and expels material outward. And that's what we see at the very beginning of this video clip. That material is now being expelled outward from the sun. Now, even though the sun has a very strong gravity, we can see some of this initial material actually escapes out into space. It is not bound by the sun. It's being sent away with greater than the sun's escape velocity, which is a lot more energy than we need to escape from someplace small like Earth. So we think about the tremendous amount of energy that is involved here to be able to expel that material away. Now, as you watch towards the end of the video clip, we can see some of that material does start falling back onto the sun in 1,000-degree plasma rain back onto the solar surface. So not all of it is moving fast enough to be able to escape. Some of it is trapped back by the sun and does fall back onto our solar surface. Now, coronal mass ejections are not rare. They happen all the time, especially when the sun is at the peak of its cycle. The peak of this cycle was last year in 2025. And in fact, you can get a few of them every day. They don't generally affect Earth unless they happen to be pointed in the direction of Earth. So if we think about how small of a cross-section the Earth is to the sun, you have to really have it lined up exactly toward Earth in order for it to affect us. However, on those rare cases, it can be extremely damaging. The amount of energy being expelled by the sun can easily overload power grids, satellites, and can fry electrical equipment. Fortunately, these don't hit us very often, but maybe every 100 or 200 years, we can get a strong coronal mass ejection that will come toward Earth. The last one we had back in the 1850s. That was known as the Carrington event and did cause significant damage. What could it do now? Well, we didn't really have any electronics to speak of back in the 1850s. The telegraph would have been one of the most advanced pieces of equipment that we had, and it did affect the telegraph lines, causing sparks in telegraph equipment at the time. What would it do now? It would really depend on how directly it hits us. A direct hit by a really strong coronal mass ejection could fry out a lot of electronics here on Earth. So that's one of the reasons we monitor what's called space weather, to be able to monitor these storms and see when the chances are that they'll actually strike our planet directly. So that was our picture of the day, titled SDO Observes a Coronal Mass Ejection. We'll be back again tomorrow for the next picture, previewed to be anti-crepuscular rays. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.